108, Algorithms and Programming. Okay, so in this section we're going to be looking at arrays and data storage. So let's have a look at the problem set out. There is a circular queue implemented with a one-dimensional array of n elements. Insertion and removal of data are performed by using an array index as a pointer. The two pointers are f and r, which just stand for front and rear of the array, are respectively used for removal and insertion. Each of the two pointers is initially 0, so f equals r equals 0 is true at the start. When the queue is empty or full, which of the following is the appropriate combination of the relations between the two pointers? So here x mod y represents the remainder of x divided by y. So let's have a quick look at what that's going to look like on the next slide. So let's just have a very brief look at what the mod function does. Let's have two numbers, 5, and let's mod 2. If we do 5 mod 2, you can see that, well, we can do 4 divided by 2, and that's going to give us 2. So let's take 4 away and divide it by 2, so our answer will be 2. And we'll have one remainder, so our remainder will be 1. So the output of this function, 5 mod 2, is equal to 1. So Q is a linear data structure in which elements are inserted from one end and the deletion of elements takes place from the other end. A one-dimensional array, say Q 1 to n, can be used to represent a queue. With this representation, two pointers, namely front and also rear, are used to indicate the two ends of the queue. So this is very similar to like an ordinary queue, where at one end people join the back of the queue, and then there'll be a big row of people, let's say just waiting to get to the till at a shop, and then here at the front, so we've got our rear, people coming in, and front where people come out once they get to the till. So it's a very similar concept to this, where we will have n elements in our queue. So we've got the two states of the queue with this representation as shown below. So the first is when the queue is empty, and the front pointer is equal to 0, and the rear pointer is equal to 0, i.e. we're not indexing anywhere on this array because we have no data in it. Let's now move on to when the queue is full, and what we have is our rear pointer is going to equal to n. So this rear pointer will basically move along until we get to our pointer at the rear, r is pointing at n. The second part of this condition is that the front pointer is equal to 1. So this front pointer will be moving along this way until we have a pointer that points to the front of the queue. So let us now consider front as f and rear as r from now on. So we've got this quicker notation, and let's see if we can find some conditions that meet the answers on the previous slide. So in the previous example we just used a normal array. So for a queue represented using an array where the r pointer reaches the end, insertion will be denied, even if there is room available at the front. One way to remove this issue is to use a circular array, or, as we've got in the title, a circular queue. Physically, a circular array is the same as an ordinary array, let's say A 1 to n this time instead of Q. Logically, all the difference is between the circular queue and the array that we had in the previous slide is that A1 comes after AN, i.e. if we increment or decrement a pointer past AN, the A1 point, we will just transfer between these two. And this is shown in a logical representation here. So here we just have our normal array points, so 1, 2, 3, 4, going all the way around the circle. And when we reach our value at n, what we can now do is we can transfer between n and 1. So these two are kind of linked in the same way 1 and 2 are linked. Okay, so here both pointers will move in a clockwise direction. This is controlled by the mod operation. For example, if the current pointer is at I, then shift to the next location will be I mod length plus 1. So that's our step to the next location. And I always has to be between 1 and length, where length is equal to n in our example. So let's just L equals n in our example on the previous slide. Thus, if length equals I, or I equals length, we're at the end of our array. So the next position for the pointer is going to be 1. With this principle, the two states of the queue, based on the insertion and deletion operations on a circular queue regarding its empty or full, will be decided as a circular queue is empty if f equals r equals 0, and a circular queue will be full if f equals r mod length plus 1, or in our case, where length equals 1, we've got f equals r mod n plus 1. And so what we can see is that our answer is going to be C from the question slide. And what we've learned in this topic is about the difference between a normal array and a circular array and how this can be implemented so we've got a dynamic queue.